So good afternoon. So this is my presentation for mechanical base of the exercise, and I had jumping as my motion. So let's get right into it. So mechanical change task I was issued was jumping. The key variable of interest was the takeoff velocity of hips. And the implemented change was the graded arm swing, grade to arm swing. So as you can see here, we have here minimal arm swing, the first test, and then the second test was graded arm swing. So the video capture I used was I used an iPhone XR. Frame rate was 30 frames per second. That's pretty standard for an iPhone. ISO was 400. It was 1920 by 1080p. Shutter speed was 1 out of 250. Um, Step length calculation. So very interesting, but basically, yeah. So you want to have a calibration stick, and that's roughly 0.52 meters. Then you want to use a tracker. Uh, with the tracker, you want to mainly find the X and Y axes. Time's not really necessary for this, but you can add it anyway if you wish. But yeah, you want the X and Y axes on tracker, X and Y axes on the tracker, and then after that, you want to transfer the data onto Excel. Now through Excel, you want to filter it, and that's just because there is a high chance that when you manually track the movement, there is a good chance that you might misclick or have some sort of human error, be a bit inaccurate. Therefore, the filter data allows for a more accurate result. So anyway, once you filter the data, you want to use a formula. There's two formulas you want to use. First, you want to determine the velocity. It's provided here, so x minus y divided by 2 out of 30. Obviously, if you're using like a higher frame rate camera, like a 60 frames per second, you wouldn't use 30, you'd use 60 instead of 30. So that determines the velocity. And then once you determine the velocity, you then want to find the modulus. So the formula here is a square root of x to the power of 2 plus y to the power of 2. And that gives you the modulus, as you can see here. Now the results. So this data provided by Excel. So it was expected, but I'll explain it more. So the arm swing showed greater velocity compared to no arm swing. As you can see here, this is the velocity of the arm swing versus the no arm swing velocity. You can see there's a higher peak versus a lower, well, a very lower peak. Also, there was a high vertical jump. So I used the VertTech to see how high I could jump and hit. So with the arm swing, I got roughly 25 inches, and the no arm swing was 19 inches. So about a 20% increase by using arm swing. So the concepts related to biomechanics. So a couple concepts here. So the first concept is linear kinematics. So linear kinematics is related to jumping because it can help us understand the motion of the body during jump, such as the height and distance of the jump, as you can see here. We can further analyze the speed, acceleration, and displacement of the body. Therefore, this information can be used to calculate the height and distance of the jump. This can also help us, optimize technique of the jump. This can lead to better performance. And also, it helps us understand the human body more, and then the force of gravity and the force of exertion of human muscles. And obviously, yeah, how to find optimal technique, how to exert more force so we can jump higher. The concept two is Newton's second law, which is force equals mass times acceleration. Newton's law is related to jumping because it explains the relationship between acceleration and the force of the body. In the case of jumping, the force of the muscles acting on the body determines the acceleration of the body, which determines the height and distance of the jump. So basically, if there's more force produced by the muscles, the higher and the further the jump will be. So with the arm swing, as shown here, because I used my arms, I used more muscle, so there's more force provided, which led to a greater jump and more momentum as well. And then the last concept is work, power, and energy. So power, related to jumping because it measures how quickly work can be done. In this case of jumping, the work done is a product of the force applied and the distance moved. The power of the muscles determine how quickly they can generate the force needed to lift the body off the ground, how quickly they can do that to work to propel the body through the air. So therefore, more power the muscles can generate, as I said before, the higher and further the jump will be. So that was my presentation. Those are my concepts. Thank you for listening. Have a good day.